Good morning. Our project is the O-ring feeder. There's myself, Brian Albert, Jerry Koenig, and our advisor, Dr. Castellanos.
O-rings are extensively used across the world in manufacturing. The most common way of O-ring distribution are bowl feeders. The problem with this is that they can be expensive, messy, and difficult to develop for certain products. The O-ring feeder could be a new generation of O-ring distribution. It's a fraction of the cost, has no mess, as much as you're in development, and has an equal, if not greater, efficiency than typical bowl feeders. A typical price for bowl feeder will cost you thousands of dollars, whereas an O-ring feeder will just set you back a couple hundred. It'll have the same, if not a greater, O-ring feed rate of at least 20 per minute, and it's a much more compact machine, saving you plenty of floor space. Here's the overview of our system, starting with the Atmega 328P microcontroller. Using this, we can control the start and stop process. It'll control the position switch connected to the LCD display to keep count of how many O-rings pass through the machine, as well as controlling the motor driver to our NEMA 17 stepper motor that controls the rotation of the gear. Here's an overview of our motor and driver subsystem. We'll be using the Easy Driver motor controller to control our NEMA 17 stepper motor. With this configuration, we have enough power to overcome any potential jams that may occur when driving the disc. Next up, we have our LCD display and sensor subsystem. The LCD display will show the total count of O-rings that have passed through, as well as the total runtime, and will reset when the machine is turned off and turned back on again. The trigger sensor is used on top of the gear to help keep track of the total count and sends the amount to the LCD display through the microcontroller.
During the testing of our prototype, we ran into a few things that caused us to make modifications to the feed disk as well as the feed slot. The feed disk was modified so that the O-rings are more likely to fall into place within the disk as it rotates around. As was said before, the feed slot was also modified so that there is now a recession in the plate, allowing for O-rings to fall slightly more within the disk. This was made to ensure that O-rings will fall through the opening in the plate instead of skipping over the opening. Here is a demo of our motor turning our feeding disc.
Here we have our O-ring counter and runtime display. To the right is our wiring diagram for prototyping using a Atmega 328P microcontroller on a breadboard with an LCD screen. This is used to program so that our LCD would display the count of O-rings passed through the machine as well as the runtime of the machine. To the left is our code used in the microcontroller. We have our variables at the top as well as a quick loop for running the count increments, and then a secondary loop for the runtime to increment. Here we have a demo of our LCD screen showing the counting runtime as well as one of the counts of an O-ring passing through. Lastly, we have our work division. We have Jerry as team leader. I was team coordinator, Jerry for doing cost and schedule lead, as well as marketing. I was in charge of the systems, Jerry did testing, I worked on software and programming, I ran as the EE, whereas Jerry was the ME.